Hello everyone and welcome back to Ronnie Explains. So in today's video I'm going to take you through the process of making a 4-bit counter. In our last video we designed a 3-bit counter, and we are also going to see the difference between these two counters when it comes to making the logic. So uh, if you look at the screen, we have a similar circuit as the one that we had before, but only that this time we are having inputs to the hexadecimal display. All the 4 inputs have been connected and all of them are active. In the other one, the third input, which is here, was connected to a switch that was always turned off. The difference between a 4-bit counter and a 3-bit counter is a 3-bit counter was counting from 0 to 7 and going back to 0 and counting again. So it was a sequential circuit. A 4-bit counter is also a sequential circuit, but now it counts from 0 to 15. So that is what we want to implement here. So I will come here and then record my states 0, 1, like that. Then I will come here, drag this, and have my values up to 15, like that. Then here I'll also have the binary numbers, like that. And here I'll have ones, drag them that way. Then I will copy paste this here and paste it here, like that, and also paste it down here. Then I will now take them in twos, like this, and paste them like this. Like that. Then I take them in ones, like that, and paste them here. Maybe copy all of that and paste it here. So that's what we have. I will label them as A, B, C, and D. And those are my input values. And the current state is represented by N. On this other side, the next states are going to be represented by N plus 1. And therefore, this other side, I will be having these states from here to 15. So it means I will have, if this is state 0, the next state should be 1. So I will have these states here as the next states in this point here, down here. Then the final state, which is this, will be down here. And similarly, I'll also do the same with the binary codes. I'll copy from 1 to 15 and paste them here. And then I'll take the first one, the first state, which was state 0, copy it and paste it down here. Now I'll have to give them the names. The first one here is A out, followed by B out, followed by C out, and finally followed by D out. Now, I can give them some colors just so that they appear a little bit distinct and easy to follow. So I will come to background colors, and then the first one I'll just give it green. And for the next states here, I'll give it a color like purple. For this one, so this is how it looks like. Maybe I can center everything, so I'll just come to alignment and center them like that. Then I will now begin making the kernel maps for this. I realize that here, unlike the 3-bit counter, in the 3-bit counter, the column of D was all zeros, and that is because we were counting from 0 to 7. And even from this table, if you look at it, then you realize that from 0 to 7 is zeros all through, and that represents a part of a 3-bit counter. But if you want to implement the 4-bit counter, then you continue in the column of D, you continue with ones, and that's what brings the difference between the two. So now that I have this, I'll come here and make a kernel map. This point here, I'll merge this. I'll also merge that. Then I'll merge this here, and then I'll merge this. So the first merged cells, call it A, and this is gonna be B. This is C, and finally this here is D. I'll just justify A towards the right. So I'll come here and then I bring it towards the right. Now C and D are gonna be centered, so I'll put them like that. Then I'll bolden everything. Then I will enhance the necessary borders for A, B, C, and D. So at this point, at the right border, I'm going to give it a different color and enhance its line weight. Then do the same with B, this other side. So I'll come here and then highlight them like that. And finally, this one also, I'll highlight the top one. So this kind of map, I'm going to copy it and paste it. The first one, which is this one, represents the value of A out, and it's equal to some logical expression. The same way this other one here also represents the value of B out, and it's equal to some logical expression also. Then down here, we also have this one as C out, also equal to some logical expression. And finally, we have this as D out, and also it's equal to some logical expression. So therefore, in A out, we are going to feed all these values that we have here. And these values that we are having here, we have 1 0 1 0, then 1 0 1 0. So here we are going to have 1 0 1 0, and then here you also have 1 0 1 0. So here we also have 1 0 1 0, and then here we also have 1 0 1 0. Then I will just center align everything here, and then form the group. The only group I can see is this group here, and that group is entirely out of A, so therefore that is A prime. It's the only group that I have, so I'll just have to move to the next, which is B out. The column for B out is this column here. So this column, I am having 0 1 1 0. So here I have 0 1 1 0. Then on this other side, I have 0 1 1 0 again. So here is 0 1 1 0. Then on this other side here, I will be having 0 1 1 0 again. So here I have 0 1 1 0, and then finally on this other side I have 0 1 1 0. That's that one. So 0 1 1 0. I'll also center align everything in the kernel map. So then I form the groups. So the only groups I can see is this group that I'm representing in green, and then I also have this group here that I'm representing in blue. The green group is entirely out of A, so that is A prime. It is completely in B, that is B. Then partly in the others, we join it to the next group using an OR gate. Then we go to the blue group, which is entirely in A, so that's A, and entirely out of B, so that is B prime. And then it is partly in the others. So that is, this is the logical expression for B out. I'll have to highlight this and freeze some cells here for easy manipulation. So I'll come to view, then I come to freeze, and then I freeze up to 18. So that is done. Now, so for C out is this column here. And what I'm going to do is I'm going to fill in this value. So the first value is 0, 0, 0, 1. I'll fill it here. That's 0, 0, 0, and 1. Then on this other side, I'll have 1, 1, 1, 0. So here I have 1, 1, 1, 0. Then this other side, I'll have 0, 0, 0, 1. That's from here, 0, 0, 0, 1. So this is 0, 0, 0, and 1. Then for this other column that you're having there is the very last one, which is 1, 1, 1, 0. So here we have 1, 1, 1, and 0. So in forming the logical expression, so first I'll have to center everything here. Then I'll form the groups. So the groups that I can see, the big groups, the first big group is this group here, that group. And this group here, it is simply out of A, so that's A prime. It is completely in C, so that's C. Then it's partly in B and also partly in D. I connect it using an OR gate to the next group. The next big group that I can see is this group here that I'm representing in color orange. And that group, it is B prime because it's completely out of B, so that's B prime. Then it is completely in C, so that's C. And it is partly in A and also partly in B. Then I connect it using an OR gate to the next group. The next group is this group here, and I'll represent that group with color blue. So this group is completely in A, so that's A. It's also in B, all of it, so that's B. And it is completely out of C, so that's C prime. And it is partly in D, so we don't consider D as an option. Then we work with the last one, which is D out. Column for D out is this one. So we have 0, 0, 0, 0 in this column, so that's 0, 0, 0, 0. Then this other side, so we have 0, 0, 0, 1 here, so that's 0, 0, 0, 1. Then in this column here, we have 1, 1, 1, 1. So that's 1, 1, 1, 1. And then in this column, we have 1, 1, 1, 0. So here, 1, 1, 1, and 0. For D out, the first large group that I can see here, I can see this group here. So I'll represent its background with color yellow. And this group is entirely out of A, so that's A prime. It is partly in B. B it's not an option. Partly in C. C it's also not an option, but it's entirely in D, so that's D. Then the next group is this group here, which is also a group of 4. This group here is completely out of C, so that's C prime, but it is completely in D, so that's D. It's partly in the others, so they are not an option. I connect it using an OR gate to the next group. The next big group that I can see here is this group here, which is also a group of 4. So I'll give it color purple, and that group is completely out of B, so that's B prime. Then it is partly in C, so C is not an option. It is completely in D, so then we say D, and it is partly in A, so A is also not an option. The last group that we are having is this group. It only forms a group alone because there is no other ones that it can form groups with. So then we represent it using this orange color and connecting it with an OR gate. It is completely in A, so that's A. It is completely in B, so B. It is completely in C, so that's C. And it is completely out of D, so that's D prime. So we've finished forming all our logical expression. I can unfreeze the frozen cells. So I'll come to view, then freeze no rows. So everything has been unfrozen. Then I'll come and launch my software. I'll come to File, then Save As, and I will save it to its own new folder. And this folder, I'll call it like that. Then I will open it. So this file name here, I'll call it circuit.hds. So I'll come to layers, check instant labels, import labels, then view magnetic grid 1/8 is already zoomed. So I am going to form the expressions here and also make the logic in this space. Because it's a 4-bit counter, I'll need 4 D-latches. So I'll create flip-flops, then DFFR. So I'll have that first one, then I have this, then I have that and that. I have to zoom this region. Now the name of the first one is D out. The name of the second one is C out. Then the name of this is B out. And finally, the name of this last one here is A out. On this other side, so I can reduce the size of this window to cross-check with my spreadsheet document. So for A out, that's this one. So I'll start filling them in from D out because D out is at the very top. So it's this one. For the 2 input AND gates, I have 3 of them, A not D, C not D, and B not D. So I will put them here. So create gates AND gate, then I have the first one, which is this, and then I'll have the second one, which is this, and then the third one, which is this. The name of the first one is A not D. Then I say okay. The name of the second one is B0D. Then the name of the third one, um, the name of the second one is C0D. And then the name of the third one is B0D. Then I will have a 4 input AND gate here. So I'll create gates and 4 input, and I will have it here. So for the 4 input AND gate, the name is ABC D naught. Then I move to the next, which is C out. So C out is this here. We have A naught C, and we have B naught C, then ABC naught. So I'll copy this and paste it here. Again, copy it and paste it here. Now the name of this here is A naught C, and the name of this here is B naught C. Then the third one is a 3 input gate, so I'll create gates, so 3 input AND gate. Then I put it somewhere here. Its name is ABC naught, like that. Then I move to the next, which is B out. So B out has 2 input OR gates, so I'll copy this, put it here, then copy it and put it here. So the name of the first one is A naught B. The name of the second one is A B naught. Then I move to the last one. The last one is A out, and it's simply A naught because that's a single signal that is flowing, so we don't require any gate for it. So having made this, I am going to connect the latches to the gates. So I will begin by A naught. So I connect all A naughts. So the first A naught is here. The next A naught is this one here. Maybe the wire is a bit faint, so I can remove the glow mode. So I'll come to layers and uncheck the glow mode so that it's much visible. So another A naught is this one here, so I'll add a wire segment here and connect it here. Then I connect S. So the first A is down here, then the next A is here, then I add another wire segment and I connect it here. Then A's have been connected. The next is B prime. So the first is this one here, then another one is this one here, and then another one is this B prime here, and all B primes have been connected. So the next is B. So the first B is this one down here, this here. The next B is this one. So I'll come here, add a wire segment and connect this. Then the next B is here, so I'll come here, wire, add segment, and connect that. Then all the B's have been connected, so I'll have to connect the C prime. So I'll connect this. The first one that I can see is this one over here, so I'll connect this C prime. Then the next C prime is here, down here, so I'll connect this from here, add wire segment, and come here and connect this. So all the C primes are also connected, so I connect C. So C, the first C that I can see here is this C here, so I will come down here and connect that. Then another C is this C here, so I'll add a wire segment here, and then I'll connect this. Then I will also connect this one here, so add wire segment and then connect this, and all the C's have been connected, so I need to connect the D primes. So I will pick this from here and connect the D primes that I can see. I can see this one here, and that is the only D prime that I can see. So the next is to connect all the D's. So I will come here and then I connect this D here, and I will also connect this D here. So this, then I connect this D here. So I'll add a wire segment. Then all the D's have been connected. So I need to combine this using some OR gates. So I'll begin by combining the values of D out. So if you look at the spreadsheet document, then D out we have 1, 2, 3, 4. So that's 4 input OR gates. So over here, I'll create gates, then OR gate 4 input, and I'll put it here. The name of this will be A prime D or C prime D or B prime D or ABCD prime. So then I'll connect this here to this, then I'll connect this like that, then connect this here, and finally connect this here. Then I move to the next, which is C out, and C out I have 3 of them, so I'll create a 3 input OR gate, and that will be put here. The name of that will be A prime C or B prime C or ABC prime. Then I will connect A prime C, and then I connect B prime C, then ABC prime, like that. Then I will have to connect the values of B out. That's two input OR gates. So I'll create gates and two input OR gates. So I'll put it somewhere here. Its name is going to be A prime B or A B prime. So A prime B will be connected to this, and AB prime will be connected there. The expression for A out is a single signal, so we don't require any OR gate. So over here, I will have to enlarge this window, then view zoom fit. That's how it looks like. So this other side, I'm going to put a clock generator in form of a pulse switch and a reset button. So I'll create IO, then pulse switch. I'll put it here and I'll name it as clock. Then down here, I'll also create IPin switch, which will be my reset, and I'll name it as reset. So I'll connect the clock to all the clock ports. So I'll connect all this like this, then add wire segment and connect it to all the ports. That way. Then for my reset, I'll also do the same, connect it to all the reset ports. That way. And then I will start connecting these values here. So I'll just zoom it a bit in, and this was the value of D out. So therefore, it's going to be connected to D out here. Then this here will be the value of C out. So it's going to be connected to C out, which is here. And this one here is the value of B out. So it's also going to be connected to B out here. And finally, A out, the value was A prime. So I'll connect A prime from here or from here. So it depends with where you want to connect it. So I'll add a wire segment and just come here and connect it up here. So the next thing is to create my output LEDs. So I'll move up a bit, then come here, create output LEDs, and put 4 of them because we are working in 4 bits. So I'll have 1, 2, 3, and 4. The name of this will be D out. This will be C out. This here will be B out, and finally this will be A out. Now I'll have to connect all the values here. So I'll I'll come to layers, then highlight the wires. So A out will be connected to this here. So I will come to A, and at this point here, just a bit. So view magnetic grid 1/8. So I'll pick it from here, add segment, and connect that to A out. Now for B, I'll also come to this point, add segment, and connect it to B out. For C, I'll also come here, add segment, and connect it to C out. And finally for D, I'll add segment and connect it to D out. So that's how the circuit looks like. We have to check for any potential errors. So options, check design, says the design is okay. So I'll have to see if it counts. So activate the set and reset. So I'll first come here in layers and bring back the glow mode. So then I activate the reset and then I start counting. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the next step is to make the tester circuit. So I'll come here to edit and create symbol. Then I'll come to file, then new, and save changes, save. So I'll save them. And in this point here, I'll have to check my layers. So all of them are well checked, and then I'll come to view and select magnetic grid 1/8. So I'll right click and create a sub design, and it will be for this circuit that we just created. So I'll zoom it that way. This other side, I'll create output, which is an hexadecimal display, and I'll put it somewhere here. So then I connect this, like this, like that, like that. On this other side, I'll have to automate it by creating a clock generator here. So Let me just move it a bit this other side, and the name of this is clock, and also create a reset button down here. So create ipin switch and name this as reset. The name of this sub-design is a 4-bit counter. So I will connect the reset to the reset port and the clock to the clock port. Then I will activate the reset and the clock, and then it starts counting. So we have to see that it counts up to F and comes back to 0. So that's it, guys. If you have any questions about this design, then my email is in the description. You can email me or write in the comment section, then I'll clarify. Again, for those who have not subscribed, you can subscribe to the channel for more informative videos and turn on the notification bell. So until next time, I hope to see you. Bye.